Now we're going to talk about solutions to absolute value equations. For real numbers a and b, an equation of the form absolute value of a equals b, and I guess I should have made that a capital A, but whatever. Oh, I guess I can do that now, can't I? The magic of real-time editing. Boom. Boom. There we go. Look at that. Isn't that amazing? So an equation of the form absolute value of a equals b with b greater than or equal to 0, we'll have the solutions when a equals b or a equals the negative of b. And think of it as the absolute value. If a was b, or if a was negative b, the absolute value made it positive. So that's what we get. So if b is less than 0, the equation absolute value of a equals b has no solutions, because you can't have an absolute value producing a negative. I should say, you can't have the absolute value of a real number produce a negative. That might give you some foreshadowing there. Okay. How to find horizontal intercepts of an absolute value function. Set the function equal to 0. Isolate the absolute value term. Use absolute value of a equals b to write a equals b or negative a equals b. Let's say the negative of a was b, which means a equals negative b. To assume b is greater than 0, solve for x. So for the function f of x equals absolute value of 2x minus 1 quantity minus 3, find the values of x such that f of x equals 0. So we're going to take the absolute value of 2x minus 1 minus 3 and set it equal to 0. So the absolute value of 2x minus 1 equals 3. And now we have our two cases, So 2x minus 1 equals 3, or I'm just going to do it this way, 2x minus 1 equals the opposite of 3. Because that quantity would have been the opposite, and then the opposite value made it positive. So we solve each of these independently. Add 1 to both parts. 2x equals 4. Divide by 2. X equals 2. Add 1 to both sides there. 2x equals negative 2, or x equals negative 1. So those are our solutions for this one. Now for example 5, we are going to solve this. So we want to get the absolute value by itself by subtracting 45. So 4x plus 8 absolute value equals 40. So 4x plus 8 equals 40, or 4x plus 8 equals the opposite of 40, negative 40. So we subtract the 8. 4x equals 32. Divide by 4. So x equals 8 is one solution. Subtracting 8. 4x equals negative 48. And divide by 4. So x equals negative 12. So these are the solutions to this equation there. Now we're going to see where this graph intersects the horizontal and vertical axes. So we first take and say, for the x-axis, negative absolute value of x plus 2 plus 3 equals 0. So I can subtract 3 from both sides, and negative absolute value of x plus 2 equals negative 3. Now we say the absolute value can't be a negative, but this is a negative absolute value is a negative, so I can divide both by negative 1. So absolute value of x plus 2 equals 3. That means that x plus 2 is 3, or x plus 2 is negative 3. And we can subtract the 2. X is 1. Subtract the 2. X is negative 5. So the x-intercepts are going to be at 1, 0, and negative 5, 0. Save some space over here for the y-intercept. At the y-intercept, x is 0. So basically look for f of 0. It's going to be negative absolute value of 0 plus 2 plus 3. So that's negative of absolute value of 2 plus 3. So negative 2 plus 3, which is 1. So at 0, 1 is the y-intercept. So for the x-intercept, I set the expression equal to 0 and solved. For the y-intercept, I put 0 in for x because x is 0 at the y-axis. Okay, how to solve an absolute value inequality. So this is the form absolute value of x minus a is less than b, less than or equal to b. So find the boundary points by solving the equals. And then we do test intervals. Oh my gosh, what a typo. There we go. Created by the boundary points to determine where the absolute value of x minus a is b. Let's be consistent. There we go. Write the interval or union of intervals satisfying the inequality in interval or inequality notation. Okay, so here's the way I typically do this. So this is a less than. So when it's worked out down to be a less than, it's going to be an and case. So I can write this as -6 is less than or equal to x plus 2 less than or equal to 6. Then I can subtract the 2 from all three parts, and -8 is less than or equal to x less than or equal to 4. So my interval would be bracket -8 comma 4 bracket. How to solve for the set of inputs, absolute value function produces negative or positive outputs. Set the function equal to 0 and solve for the boundary points. The solution set, use test points. So yeah, we can do that. I don't think it's really necessary to get into that much detail here. Now, when I solve this type, this is going to be, I'll show you in a second. Greater means or. And I don't really like word games like this. I like conceptual ideas. But here we divide by -2. We have the absolute value of k minus 4. When you divide by a negative or multiply by a negative, it switches the sign. It becomes greater than or equal to 4. Now, this is a greater case. It's a greater case. So I do k minus 4 is greater than or equal to 4, or, this is a key word, this will give us a union, or we would have k minus 4 is less than or equal to the negative of 4. So notice it was a 4 here, it's the -4 here. So I changed signs. I had changed signs in the previous one too, by the way. If you look how that one worked out. So I write it as it is, x plus 2 less than or equal to 6. It's also, I change the sign to greater than. So it's less than 6, greater than or equal to -6. So I change the sign and change the sign of the number and change the inequality sign. So I'm doing the same thing here on the greater. I write it out as it is without the absolute values. I do an or, then I write it out, but I switch the inequality and I switch the sign of the number. So let's just solve these now. Add 4, k is greater than or equal to 8, or add 4, k is less than or equal to 0. So what we have here, this is the interval from 8 to infinity, and this is the interval from -infinity up to 0. Now, when we write these, we have to write them from small to large. So I'm going to put this one first. -infinity up to 0. Remember, I'm also doing parentheses on infinity or -infinity. Union that with 8 to infinity. And that's it. Okay. Now go do the homework for 1.6.